Hello friends, today I am going to discuss about the transition between inorganic electronics to the organic electronics, right? So over the last 20 decades, organic electronics shows a potential application in the field of the photonics and the electronics application due to their rapid development of the material synthesis and the performance, right? Now, organic electronics that can be designed by the organic semiconductor, right? So organic semiconductor, this semiconductor shows a potential devotion in the field of the photonics application for designing organic semiconductor based optoelectronic devices due to their organic semiconductor due to their extraordinary thermal and optical properties. Okay, and apart from this, it has the capability to absorb photon, transmit photons, and detect photons. Okay, it has the good capability to absorb, to transmit, and to detect the photons. And so organic semiconductor, one of the most important properties of the organic semiconductor is that strong absorption coefficient. Okay, 10 to the power 5 per centimeter. Okay, it has the strong optical absorption coefficient as compared to the inorganic semiconductors, right? So due to this strong absorption coefficient, if we design organic optoelectronic based device by employing organic semiconductor, it will be more superior as compared to if we design the organic semiconductor based electronic device due to the strong optical absorption property and due to the superior optical properties, right? So if you want to design the organic semiconductor based optoelectronic devices, three main devices are important. One is the organic photodetector or organic solar cell, OPD, OC, okay, OSC. Second is the organic light emitting diode, OLED. Third is the organic photo transistor. Okay, this is OPT, right? So organic light emitting diode, okay, it can use in the flexible display industries, okay, due to their flexibility and the flexibility flexibility properties. Okay, next is the you can use the organic photodetector or organic solar cell in the renewable industries, okay, due to their large area and simple fabrication process. Okay, and organic phototransistor, this can normally used in the electronic industry as well as the photonic industry to detect any kind of the biological substance. Okay, and to normally it can use for sensing applications, right? So due to their flexibility and the lightweight. Okay, so but organic light emitting diode, it is already commercialized. Okay, but due to some drawbacks like low mobility and the low speed as well as the low stability, this organic photodetector and the organic phototransistors are not completely commercialized. The research is going on. Okay, now among these three devices, all the three devices are potential devices. Among these three devices, I am going to discuss about the organic photodetector. Why photodetector I am considering? Because photodetector influence the performance of the entire optical communication system or entire optoelectronic integrated circuit. Okay. Now several last few decades, several materials are made to achieve the performance of the photodetector. Okay. So among them, inorganic semiconductor like group 3, 5 compounds. Okay. And different kind of the metallic oxide. Okay. These materials are shows extraordinary properties. Okay. In the field of the electronic application. Okay. Mainly in the field of the electronic application and the photonic applications also. Right. Why? Because these materials have the small exciton binding energy, high mobility and the high stability. Okay. Due to these features, it these materials were widely used. Okay. But some more drawbacks are there, like rigid, okay, high driving voltage, high fabrication, temperature, inflexibility issue, and lots of features are there. Okay. And another thing, so for fabricating the inorganic semiconductor based devices, okay, you need the ultra pure substrate, okay, which is very difficult to design, because if you want to need ultra pure substrate, so high processing cost is there. Okay. And another feature is the limited color tunability. Okay. So if you want to tune the color, if you want to change the optoelectronic properties of the inorganic optoelectronic devices, so how you can design, how you can tune the optoelectronic properties by co-mixing or co-doping of the different materials. But if you want to design such kind of the device, you need complex synthesis procedure. This is the one of the important drawbacks. Okay. Inflexibility issue is there, right? Inflexibility issue is there. Now, but in the modern technology, okay, the modern technology and modern photonic industry and the light sensing industries, these industries need portable and the wearable devices. Okay, portable and the wearable devices. Okay, modern industries. Okay. So if we choose such kind of the materials which can be used for portable and wearable device, then this kind of the device we can use for modern technology. Okay. So like graphene oxide, carbon nanotube, perovskite, organic semiconductor can used for flexible and wearable industries. Why? It has this organic semiconductor and this graphene oxide and carbon nanotube. Such kind of the materials have some features like fragile, low fabrication temperature, low driving voltage, outstanding band detection capability. recyclability. But though these features are there, but some limitations are also there, like a low mobility and low stability and low response speed. Due to these drawbacks, so some kind of the organic optoelectronic devices are not completely commercialized. Okay, so in order to choose proper, so we have to choose the proper material and the proper fabrication process to design high performance organic photodetector which should be compatible with the CMOS technology. Okay, so among all the materials, whatever materials I told, like graphene oxide, and carbon nanotube, perovskite material, and organic semiconductors are there, right? So among these materials, organic semiconductor is the more versatile, because if you want to design any device, right, you have to check all the parameters. Okay, how it is compatible with the other technologies. Okay, how we can use this thing, how it can be commercialized. Okay, so organic semiconductor, that is more versatile. Why? It has main parameter, that is strong optical absorption coefficient. If you want to design any kind of the optoelectronic devices, strong optical absorption coefficient is required, right? So organic semiconductor has strong optical absorption coefficient. Okay, wide band detection capability. Okay, then simple fabrication process with low cost and lightweight also. Okay, and if you want to fabricate, if you want to deposit organic semiconductor, we can deposit organic semiconductor in various substrate like paper, cloth, plastic, glass. Okay, so if we use such kind of the substrate, this kind of the substrate we can use for the flexible and portable and wearable industries. Okay, so that's why, so this material is highly compatible with the various substrate. Okay, so that's why we can use the organic semiconductor in the portable industry, flexible industry, as well as the wearable industries. Okay, now in the last point I want to discuss about the comparison between organic electronics and the inorganic electronics. Okay, organic, so I am summarizing this thing. There is the inorganic electronics. Why we will choose the organic electronics? Though all maximum research papers had been done on the inorganic semiconductors, still why we will use the organic electronics, right? First is the cost. Okay, low capital, 1 to 10 billion. Okay, material, polymer, plastic. Okay, rigid material, metal and semiconductor. Okay, next is the size. This is for large area fabrication. Okay, millimeter to meter. This is from micrometer to millimeter. Fabrication process. Okay, simple deposition oblique spin coating. Printing. Okay, here is the lithography. Lithography is one of the complex fabrication process. Lithography condition, required condition. Okay, here ambient condition. Ambient condition means we can design the organic electronics based device in at room temperature. No low processing temperature is required. Okay, this is the ambient condition. Here is the low temperature is required. Okay, so this is about the why I will choose the organic electronics instead of the inorganic electronics. Okay, so next class I will discuss about the main topic of the organic electronics. What is the organic semiconductor? What is the physics between the organic semiconductor? How many properties are there in organic semiconductor? Thank you.